In 20 through 38, determine whether the statement is true or false. Justify your answer with a proof or a counterexample as appropriate. In each case, use only the definitions of the terms and the assumptions listed on page 161, not any previously established properties. For all non-negative real numbers a and b, the square root of a times b equals the square root of a times the square root of b. Note that if x is a non-negative real number, then there is a unique non-negative real number y, denoted the square root of x, such that y squared equals x. Now, this is an algebraic property that I was taught in grade school, so that's an indication that we should probably prove that this statement is true rather than trying to prove that the statement is false by using a counterexample. So to start this proof, since the statement is a universally quantified statement about integers a and b, since this statement is a universally quantified statement about non-negative real numbers a and b, we can start with an assumption that instantiates these two variables a and b as non-negative real numbers. So let a and b be non-negative real numbers. Now our goal is to show that this property is true. Now we have an important note that we need to utilize in this proof. It says if x is a non-negative real number, well, that premise is true when x is a and when x is b, since a and b are non-negative real numbers. Then there is a unique non-negative real number y, denoted the square root of x, such that y squared equals x. So since a and b are instances of these non-negative real numbers, then a and b satisfy the premise of this implication. Since a and b are non-negative real numbers, then there are unique non-negative real numbers, we'll call them x and y, denoted as the square root of a and the square root of b, respectively, such that x squared equals a and y squared equals b. So we need to prove that the square root of ab equals the square root of a times the square root of b. So let's consider the square root of a times the square root of b, since the square root of a and the square root of b are just x and y. So what happens when we multiply x and y together? Well, we should get the square root of ab. Let's investigate these two objects. Since a and b are non-negative real numbers, then a times b is also a non-negative real number. If you multiply two non-negative real numbers together, then you get a non-negative real number. That's just an algebraic property of real numbers. Then we could say that there is a non-negative real number z, such that, which is denoted as the square root of ab, such that z squared equals a times b. Well, we know what a and b are in terms of x squared and y squared. We know that z squared equals x squared times y squared, since a and b are x squared and y squared respectively. So by substitution, which is one of the assumptions listed on page 161 that we're allowed to use here, z squared equals x squared times y squared. Now notice that x squared times y squared is equal to x times y all squared. And that's by algebra, which is one of the assumptions we can make from page 161. So this means that if we square x times y, then we get a times b. But there's only one square root of a times b, since this square root here is unique. So since the square root of a times b has one unique solution, and x times y satisfies that solution, then these two objects must be the same thing, since this solution is unique. That means that the square root of ab equals x times y, which according to our assumption is the square root of a times the square root of b. And that proves our statement. Thanks everyone, and I'll see you in the next video.